elimination method. It's different. This is what the book says how to do it. It works best when you have coefficients of all the variables, and they're not the same coefficients. That's when elimination works the best. So let's look at an example. So I have two equations. These are my two equations right now. They're they're under one another. I have 3x minus 7y equals 10, and I have 6x minus 8y equals 8. That's my linear system that I'm dealing with. What I'm going to do, what I want to have happen, is I want to be able to eliminate one of the variables, hence the name elimination method. So if I multiply my top equation here by -2, means I'm multiplying the left side by -2 and the right side by -2. I'm going to get the equation -6x plus 14y equals -20. Can everybody see that? Mm-hmm. Yes?
How did you get -2? Oh, you solved the other one, okay.
No. I got -2 because I could see that if I multiply this by -2, it's going to give me -6. And when I push it over to the other side here, I didn't change this equation at all. When I push it over to the other side, and now I add them up, my -6x and my +6x equals 0. So now I've gotten rid of my x's, and all I have are y's. I have 14y, positive 14y, plus -8y is equal to 6y. And I have -20 plus 8 is equal to -12. So I have y equals -2. So let's think about this one a little bit. I'm seeing some scrunched up faces here. Let's kind of work it backwards. Can you see that if I have these two equations right here, this equation right there and this equation right there, then I can add those two equations together, and that my -6x and my +6x are going to go away. Can everybody see that? No, I'm not getting up. Somebody who can't see that, say no. What are you talking about? Why is that true?
If you have like addition and subtraction, those and subtract the coefficients.
Well, the way I like to set up the elimination method is you're always going to add the equations. Yes. So I would be adding these equations together.
If I thought if we changed the plus into plus -8y, then we would have to subtract. Right?
Well, I did. So I had 14y plus -8y gives me 6y, right? Are you sure?
Like I remember my teacher telling us this, and he always changed both equations to addition, and then we would subtract.
Oh, so he would multiply by 2 instead of -2, and then he'd be subtracting 6x minus 6x. Okay. I do it the other way. You know, but that way would work just as well. That way would work just as well. As long as you're doing the same number times the equation, and then over here you're subtracting or adding all the terms, you're okay. Is there another question on this? Because I have a question for you. I think everybody's probably okay that if I multiply 3x minus 7 times -2, and I multiply 10 times -2, I've done the same thing to both sides, so that equation is in fact equal to that equation. Everybody's okay with that, right? Then what gives me the right to just add these equations together? You know, sometimes I'll be walking around and somebody will like add 3 or multiply 3 to get rid of a denominator, and I'll say, what gives you the right to do that? You know, because it looks to me like it's kind of arbitrary. Does it? I mean, why am I allowed to add these two equations together? What gives me the right to do that? It's good.
If they're still proportional. It's, well, the equation itself is still proportional. The one that you multiply -2.
What do you mean?
It's like, it's still in the same exact proportion. Because it's just like greater, but it's like still in the same proportion as it was before.
Okay, close. Close. That's good. Not exactly what I'm looking for, but I think you got it. Yeah, correct.
So you said why you add them?
Yeah. Why am I able to add them together to get rid of that x and?
Because it's like, they have like terms, don't
They like terms, but so what? Just because something has like terms doesn't give me the right to add it together. Yeah, Valentina?
I don't know if this was said, but like you have to eliminate and they're opposite. So then the only way to eliminate would be adding them together.
But what gives me the right to do that? Okay, so I'm gonna ask a question. Does everybody agree that 3 equals 3? No, nobody's gonna disagree with that. Does 3 equal 2 plus 1? Right, okay. Does 6x minus 8 equal 8?
According to the equation.
But they told me that it does, so I gotta trust them on that, right?
Yes.
Right? So what I'm doing over here is I'm just adding 8 to both sides of this equation. I'm doing the same thing to both sides. I'm adding 8 to this side. It just happens to take this form. And I'm adding 8 to this side. It happens to take that form. I'm adding 8 to both sides.
You're adding 8.
Yes. 6x minus 8y is equal to 8. They told me. So I decided. Would you have objected if I had this equation negative 6x plus 14y equals negative 20? Would anybody object if I added 8 to this side and added 8 to this side?
I mean, then you'll just have negative 6x plus 14y plus 8 equals,
Negative 2. That's right. But nobody would object. They did the same thing to both sides of the equation, right?
yeah.
Well, I did the same thing to both sides of the equation, except on this side I took this form 6x minus 8y, and on that side I took the form 8. I added the same thing to both sides of the equation.
I don't know. So are you saying?
How am I saying that this is 8?
Yeah.
Well, I get that it equals 8 because that's what they told us, but what do you mean with the
So if you're adding 8, how does it equal 8? If you're adding 8 to both sides, how does it equal 8?
I didn't say it's equal to 8. I said this part right here, this 6x minus 8y is equal to 8. So I added 8 to this number right there, that equation, and I added 8 to that number. I added 8 to both sides of that equation.
I don't get why you saying the top.
Oh,
okay.
I just added 8 to both sides of the equation. I just happened to do it in a way that I wanted to do it so that I can get rid of my x's right there. I mean, the reason I'm stressing this here is because, you know, there's a couple ways to do math. You know, one way is to learn the steps and do it kind of mechanically, and another way is to kind of, you know, rock it just a little bit. You know, so why am I doing that? You know? Does it have to be 8?
Yeah.
It does not have to be 8. I could add anything I want to both sides of that equation.
You're just adding, so it should.
That's exactly right.
Okay.
I am adding just for the sole purpose to be able to cancel it out. So now I can cancel out my x's, and all I have is my y's left. So I have y equals negative 2. What am I going to do with y equals negative 2? You better believe it. I'm going to plug it right in there for y.
Oh, okay.
So that now I can then solve the other equation. Right?
I think
So I want to I have to find a way to be able to solve for one of the variables. And in this way, I use this elimination method by multiplying, in this case, the top equation by -2, so that I could get this -6x, so that I know that that would cancel out the 6x. Now, I could have also, well, let's go to quote. Let's do this. So I plug my y in over here, and I get my solution, an ordered pair of -4/3, -2. My x value and my y value. You always got to write the solution of these as an ordered pair. And then I do the right thing, and I check my work. You could also check it using a graphing calculator, but that's what I have to do always with these elimination things. And with the elimination things in particular, you always want to plug them back into both original equations, because it's really easy to plug it into the wrong equation, and it's going to come out right because you made a mistake in the one that you're working on. You'll see an example of that in a minute. So let me do this.